Okay, I'm back again with the second half of the lesson on Wednesday, and that's solving for the other 5 trig ratios if we have one and a quadrant where the problem is. So the example that we're going to look at is we're given secant x equals -2, and it's found in the third quadrant. So to do these, just like what we did on the first type of problems, the first step is we need to draw our triangle. And for this case, we're going to draw a triangle in the quadrant that's given. So you're going to draw a triangle in the given quadrant. And just like when we did this for the last example, you draw it with the origin and the x-axis. So I draw an xy axis. If you've forgotten quadrants, they are numbered from the positive around counterclockwise 1, 2, 3, and 4. And because they said it's in the third quadrant, I'm going to pick a point in the third quadrant. So after I pick the point, then I always draw the triangle back with the origin and the x-axis. And the x-axis is where the right angle is. The angle that we're talking about or finding the values for is the one at the origin. So after we have that, the second step is we need to put the given trig ratio on the triangle. So put the numbers from the given trig ratio on the triangle. Now, because my trig ratio that I'm given is secant, I'm actually going to, I have to put it over 1 so I have a fraction because I don't have a fraction yet. And I need to remember that secant goes with cosine. And because it goes with cosine, the secant, I need to flip that fraction to get what cosine is. So the cosine is going to be -1/2. And when we do this, the other thing that you need to be aware of is the hypotenuse can never be negative because it represents a distance. The other two are directional along with a distance, and so you can have negative signs on opposite and adjacent, but hypotenuse cannot have a negative sign. So after I do this, then I'm going to put those two numbers around it. Adjacent would be in between the angle and the right angle. That's where the -1 goes. And the 2 is the hypotenuse, and so that goes on the longest side or across from the right angle. And now that the 3 is in the way, I'm going to move it down. And now I have to find the missing side. So step 3 is you're going to use Pythagorean's theorem to find the missing side. And that's no different than what we did the day on Monday. We had to find Pythagorean's theorem. Hypotenuse is one by itself, so you use a squared plus b squared equals c squared. C is the hypotenuse, so we'd have -1 squared plus b squared equals 2 squared. And then I solve this. 1 plus b squared equals 4. -1, we get b squared equals 3, and then you square root b equals the square root of 3, and that's our missing side. So we fill it in. Now the last thing we need to do is we need to look at the sign. Is this missing side negative? And when you do this, what you're looking at is where are we on the triangle. Going to the left is negative, that's why the 1 is negative. Going down, which is what the root 3 is, also makes that negative, so we need to worry about this, which we didn't have to worry about in the first example because the signs were already given. And the missing side for the last example was always the hypotenuse. This one, it can be the hypotenuse, but it can be also a leg. And one of the legs then we'd have to look to see if the sine's missing. So after we get that, then we go and we start writing our sine, cosine, tangent, and the ones that go with it, cosecant, secant, and cotangent. Now they did give us secant, which was -2. I flipped that and I got cosine, which is -1/2. So we have those two. The rest of them we get using the triangle. So if I did sine, it's opposite, which is -√3/2. Cosecant then is flipping that. We get -2/√3, but now I have to rationalize the answer. So I bring the root up and I end up with -2√3/3. And then tangent is opposite, which is -√3, over adjacent, which is -1. Now I need to get rid of the negative signs, and I also should probably make this just √3, and the negative signs went away. But when I flip it, I'm going to flip the original fraction, so now I'm flipping 1/√3, and then I have to rationalize this, so we end up with √3/3. And again, you're just coming up with the 6 trig ratios, in this case 5 more, and then you are done. So hopefully this helps.